Hello everyone, myself Hans. Today we are going to solve the problem of definite integral as a limit of sum. Here, three questions are given. We have to discuss three questions in the live session. First, we have to solve equation question one. Solving question one given that is limit n tends to infinity n upon square plus n square plus n upon 2 square plus n square plus dot plus of n upon n square plus n square. We have to first write in the summation form. Here is the summation, we have to write like that, that is limit of n tends to infinity, and we have to write n upon r square plus n square. This is the series we have to put in place of r, that is 1 2 3 we have to get. We can also write once again, that is summation of r is equal to 1 to n. This is the series we have to find. When putting r is equal to 1, we have to get the first series, and when putting r is equal to 2, we have to put the series 2. Then further we have to proceed to get the required series, and further we have to solve the definite integral as a limit of sum. We have to first know the following. Remember identity, that is 1 by n is written as dx, and r by n is written as x, and third is limit n tends to infinity, summation is written as integration. Then we have to further, that is limit n tends to infinity, summation r is equal to 1 to n, and from here, from denominator, we have to take common r square, that is n upon 1 plus, once again taking r square upon n square plus of 1, and from here we have to n square is adding here, that is once again taking 1 by n square is common. Further we have to solve, that is limit of n tends to infinity, summation r is equal to 1 to n, and we can also write that is n upon 1 plus r square upon n square, and 1 by n square is written as 1 by n square is written as on cross multiply, that is n square upon once again n square upon 1. This is n cube, one second, n square, taking from here n square is common, that is r upon n square is from here, that is on taking n square, it is n cube. Further we have to solve, that is limit of n tends to infinity, summation r is equal to 1 to n, and from here we have to also taking n cube is here, once again taking 1 by n common into this 1 by n, and 1 second, some mistake is happened. 1 by n square is, that is n square, 2n square is cancel, n 1 by n square. 1 second, taking common is n square, that is n square, 2n is cancelled, remaining n, that is 1 by n is taking common, remaining is 1 upon 1 plus r by n का whole square. From we have to put in place of 1 by n, that is dx, and in place of r by n we have to put x, that is further we have to solve limit of, putting limit n tends to infinity and summation r is equal to 1 to n, that is integration of 0 to 1, and in place of 1 by n, that is dx, and here is 1 plus 1 upon 1 plus, in place of r by n, that is x, that is x square dx. When solving, that is when integration solving, dx upon 1 plus x square is written as 10 inverse x, 10 inverse x, applying the limit 0 to 1. Further we have to put upper limit, that is 10 inverse of 1 and 10 0, 10 inverse of 0, putting lower limit, that is the value of 10 1 is 1045. We have to put 10 inverse into 10 pi by 4, and this is 0, so we have to further 10 inverse to 10 is cancelled out, remove, that is the remaining answer is pi by 4. The solution of equation 1 is, the answer is pi by 4. Everyone should like the session. We have to solve second problem. Please note down the solution of first problem, then we have to further proceed for second problem. We have to solve second problem. We have to solve second problem. Further we have to write here note, that is r by n is written as x, 1 by n is written as dx, and limit of n tends to infinity, summation summation is written as integration. We have to solve second problem, that is question 2. Limit of n tends to infinity. We have to write equation 2 in the given series. We can also further modification, that is n square upon n plus 0 का cube. 1 by n is written as n square upon n plus 0 का cube. When opening, that is n cube to n square is cancelled out, that is remaining is 1 by n plus of n square upon n plus 1 का cube plus of n square upon n plus 2 का cube plus dot 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 plus of, and we can also write 1 by 8n is written as n square upon n square plus n square का cube. When solving, that is 2n square n plus 2, that is n plus n का cube. When solving, that is 2n square, 2n, n plus n is 2n and 2n cube is 8n cube. 8n cube to cancel out. N plus n is 2n. Mistake is second question, that is 8n, that is n plus n is 2n cube. 2n cube is 2 is 8 and n cube is n cube. N square is cancelled out, that is 1 upon 8n. Nothing to change. Further, we have to solve taking summation of the given series, that is limit of n tends to infinity and summation of r tends to 0 to n square upon n plus r का cube. Further, we have to put in place of r, we put 0, we get the first series, and we have to put r is equal to 1, we get second, and further we have to proceed, we have to put n, we get the last series. Then from here we can also write, that is limit of n tends to infinity, summation of r is equal to 0 to n, and from here, that is taking n common from denominator, that is n square upon 1 plus r by n का cube, and we have to take n cube is common, that is n cube, and from here n cube to n square is cancelled out, remaining is n. So we have to further proceed. Limit of n tends to infinity, summation r is equal to 0 to n, and from here, that is remaining is 1 upon 1 plus r by n का cube and 1 by n. Further, we have to know 1 by n in the definite integral as a limit of sum. When solving the problem of definite integral as a limit of sum, we can change r by n is x and 1 by n is dx, and limit n tends to infinity and summation is written as integration sign. Further, we have to proceed. We can write here, that is integration of 0 to 1, and from here, that is 1 upon 1 plus, in place of r by n we have to put x, that is 1 plus x का cube, and in place of 1 by n we have to put dx. This is the required integration. Further, we have to solve the integration. We can take 1 plus x का cube into numerator, that is 0 to 1, and 1 plus x का minus of cube dx. using the formula of integration, that is xn dx, that is xn plus 1 and n plus 1. This is the formula used to solve the given integration, that is on applying limit, that is 1 plus x and minus of 3 plus 1 and minus of 3 plus 1, and 1 plus x is differentiating with respect to x, that is 1, and nothing to change, 1 dividing, that is on applying limit, that is 0 to 1. Further we have to solve 1 plus x की power minus 2, 3 minus 3 plus 1 is 2, and here is minus 3 plus 1 is minus 2. On applying limit 0 to 1, we have to apply the limit, that is in place of x we have to put 1 when applying upper limit, that is 1 plus 1 की power minus 2 upon minus 2, and minus of, on applying lower limit, that is on putting in place of x we have to 0, that is 1 की power minus 2, and minus 2 is already present. On further solving, that is minus 1 by 2 and 1 plus 1 is 2, 2 की power taking into denominator, that is 2 की power 2 is 4, 4 minus of, and from here that is 1 की power minus 2 is taking into denominator, that is minus 1 की power minus 2, that is plus of 1, and minus of minus plus, that is 1 by 2. Further we have to solve, that is minus 1 by 8 plus of 1 by 2, taking LCM, that is 16 is the LCM, and sorry 8 is the LCM, that is minus of 1, and 2 4s are 8, that is plus of 4, we have to get 3 by 8. This is the answer of the equation 2. Note down. Everyone should requested to like the live session to solve further third problem. This is the solution of second problem. We have to solve third problem. We have to solve third problem, that is limit n tends to infinity n plus 1 upon n square plus 1 का square plus of n plus 2 and n square plus 2 का square plus of n plus 3 n square plus of 3 का square plus dot 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 plus. We can also modify to change the last series, that is n plus n and n square plus n square. When solving, that is n plus n. When solving, that is n plus n is 2n upon 2n square. 2 to 2 is cancelled out and n square to n is cancelled out. Remaining is 1 by n. Nothing to change. Further, we have to write limit n tends to infinity. We have to write in the summation form, that is limit of n plus r. One second. Summation r is equal to 1 to n plus r and n square plus r square. Further, this is the summation series. When putting r is equal to 1, that is we have to get the first series, that is n plus 1 and n square plus 1 ka square. When putting r is equal to 2, we get the second. Similarly, we have to proceed same. When putting r is equal to 3, we get the third series. Similarly, we have to put n, we get the last series. Further, we have to solve limit n tends to infinity and summation of r is equal to 1 to n, and from here, from numerator we have to take n common, that is n is taking common, that is 1 plus r by n, and from denominator we have to take n square is common, that is n square is taking common, that is 1 plus r square upon n square. From here, n square to n is cancelled out, that is remaining is here n. Further, we have to solve, that is limit of n tends to infinity, summation r is equal to 1 to n, and from here, that is 1 plus r by n upon 1 plus r by n ka square. We can also write, we know in the definite integral as a limit of sum, we have to change some identities, that is r by n is written as x and 1 by n is also remaining. 1 by n is written as dx and limit n tends to infinity, summation is written as integration. We have to further proceed. We also write, that is integration of 0 to 1 and 1 plus x upon 1 plus x square dx. We have to put in place of r by n, that is x, and place in denominator we can also put r by n, that is x, that is 1 plus x square dx. This is the integration, and further we have to solve, that is integration of 0 to 1 taking 1 upon 1 plus x square dx and plus of integration of 0 to 1 x upon 1 plus x square dx. We know that dx upon 1 plus x square is written as tan inverse x, that is tan inverse x. Put the limit 0 to 1 and plus of 1. When solving the second part, we can multiply by 2 and divide by 2, that is 2x upon 1 plus x square dx. when solving second part, taking 1 plus x square is t, then 2x dt change. Let 1 plus x square is equal to t, that is on differentiating, that is 1 is 0 plus 2x dx and dt. We have to replace dx, value of dx, that is dx is equal to dt upon 2x. And from here change the limit when putting x is equal to 0, that is t is equal to 1, and when putting x is equal to 1, that is t is equal to 2. We have to also change the limit, that is from here we have to put in the first part, that is tan inverse of 1, in place of x we have to put upper limit 1, and this is the value of tan 45. From tan inverse to tan pi by 4 is removed, that is pi by 4 is remaining, plus of 1 by 2, and limit is changed when putting 0, that is 1, and when putting x is equal to 1, that is limit is 2, and from here, that is 2x is 2x upon t. We have to put 1 plus x square is equal to t, and we have to put the value of dx, that is dx is equal to dt upon 2x. From here 2x to 2x is cancelled out, and the remaining is pi by 4 plus of, when integrating with respect to t, that is 1 by 2, that is log of t, limit is 1 to 2. Further we have to solve, that is pi by 4 plus of 1 by 2, and putting on upper limit, that is in place of t we can also write first log of 1 plus x square, and limit is 1 to 2. We let here, that is 1 plus x square t. When solving the integration, we again put the value of t and further solve, that is pi by 4 plus of 1 by 2, and when putting upper limit, that is in place of x we have to put 2, that is 2 to the 4, that is log of 2 to the 4 plus 1 is log of 5, and we have to put lower limit, that is x is equal to 1, 1 plus 1 is 2, that is log 2. Further we have to write, that is pi by 4 plus 1 by 2, and using the property of log m minus n, that is log m upon n, log m upon n, that is 5 by 2. This is the required solution of the problem third. Thank you class, and thank you for watching. We can also solve one more problem once again. Once again, we have to solve one more problem. We can also solve one more problem, that is limit n tends to infinity 1 plus 1 by n into 1 plus 2 by n into dot dot 1 plus n by n की whole power 1 by n. We have to solve one more problem. Solving the given problem, we have to let the given series is equal to let y is equal to limit of n tends to infinity summation of 1 plus 1 by n and 1 plus 2 by n, and similarly we have to write 1 plus 3 by n, that is dot 1 plus n by n की whole power. Here is the whole power 1 by n. Here is the whole power 1 by n. Taking log both the side, that is log of y is equal to limit n tends to infinity log of 1 plus 1 by n and 1 plus 2 by n, and we can also like that further 1 plus 3 by n, that is dot 1 plus n by n की whole power 1 by n. Using the property of log, if log a की power n, we can also write that is n log a. Using the property, that is from here we can also write that is 1 by n is taking back, that is limit of n tends to infinity 1 by n log of 1 plus 1 by n and 1 plus 2 by n. Similarly we have to write 1 plus 3 by n dot 1 plus n by n. Using the property of log, if the once again log of mn is written as log m plus n. First we have to write multiplying with the everyone, that is everyone with the log, that is log of y is equal to limit of n tends to infinity and 1 by n taking, that is log of 1 plus 1 by n, and once again on multiplying log m into n, that is log m plus log n, that is log of 1 plus 2n and plus log of 1 plus 3 by n and plus dot 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 plus of log of 1 plus n by n. From using the property of log, when log taking log x y z and multiplying, we have to get into the addition. From here we have to get the series, that is log y is equal to limit of n tends to infinity 1 by n, and from here we can also write log of 1 plus r by n. 1 plus r by n, when we have to write the summation once again. Log of y is equal to summation of limit n tends to infinity and summation of r is equal to 1 to n. This is the required series. When putting r is equal to 1, we get the first, and similarly we have to put r is equal to 2, we get the second, and similarly we have to, in the last we have to put r is equal to n, we get the last term. We know the in the definition as the limit of sum, r by n is written as x, 1 by n is written as dx, and limit n tends to infinity summation is written as integration. We can also write it is log y is equal to integration of 0 to 1, and from here that is log 1 plus rn is written as 1 plus x, and from 1 by n is written as dx. We have to solve further, that is log 1 plus x solving the integration using the y parts formula, that is the dx is taken as first and log 1 plus s taken as second function. We have to solve, that is log y is equal to, or integration, that is log 1 plus s taken as the, once again this is taken as first function and this is second function, that is first function is taken to outside, that is log of 1 plus x, and integration of second function dx minus whole integration differentiation of first function, that is log of 1 plus x, and integration of second function that is dx and whole dx. We can solve, and the limit is 0 to 1. We have to solve, that is log y is equal to From here, that is integration of dx is x, that is x log 1 plus x is 1 plus x, and when differentiating 1 plus x with respect to x, that is 1, nothing to change, dx and whole dx, limit is 0 to 1. Further we have to solve once again, on integration of dx is x whole dx. Solving further we have to solve, that is log y is equal to x log 1 plus x, and from here we have to solving, that is minus integration of x upon 1 plus x, we have to solve x upon 1 plus x dx, whole integration is 0 to 1. We have to solve the second part of the integration, that is log y is equal to x log 1 plus x minus of, when solving, that is we have to write 1 plus x and minus x in the numerator and 1 plus x dx, and the limit is 0 to 1. From here, nothing to change, minus to minus is cancelled, remaining is x upon 1 plus x. We have to solve the integration, further we have to modify it. From here, that is log y is equal to integration of bracket x log 1 plus x, and from here we have to write, that is taking first part into denominator, that is minus of integration 1 plus x upon 1 plus x, and we have to take minus, and minus is plus, that is plus of integration 1 upon 1 plus x. This is also dx, and here is also dx. Limit is 0 to 1. From here, 1 plus x to 1 plus x is cancelled out, remaining is dx. On integration of dx is x, we can also write log y is equal to bracket x log 1 plus x, and integration of dx is minus of x, and from here, that is dx upon 1 plus x is log x plus of log 1 plus x. When 1 plus x differentiating with respect to x, that is 1, nothing to change. On applying the limit 0 to 1, we have to first put the upper limit, that is log y is equal to, we have to first apply upper limit, that is in place of x we have to write 1, here is 1 log, and x in place of 1, that is log 2, and from here, that is we have to put minus of 1, from here we have to put x is equal to 1, that is plus of log 2, and further we have to proceed with lower limit. We have to put here 0, that is first part is all 0, and putting here x is also 0, and from here we have to put log 1 plus x, in place of x we have to put 0, that is log 1, and log 1 is also 0. Then further log y is equal to, once again, log 2 plus log 2 is 2 log 2 minus of 1, and we can also write log की power 2 की power 2, that is log 4 minus 1, and here is log y, and from here that is y is equal, once again, log 4 minus 1, and that is log 1, we can also write once again log m by n, that is nothing to change, that is log 1 is 1e, that is y is equal to, once again, y is equal to e to the power log 4 minus 1. This is the required solution of the given problem.